A body is placed in YZ plane means body is two-dimensional. Yeah, a body is placed in YZ plane. If its moment of inertia, a body is placed in YZ plane. If its moment of inertia about x-axis is 40 and about y-axis, its moment of inertia about x-axis is 40 and about y-axis is 10, then find its I about z-axis. If its moment of inertia about x-axis is 40 and about y-axis is 10, find its I about z-axis. 30 will come. Yeah, okay, no problem. So point is depending on plane, our formula will change. Yeah, depending on plane. Some people are saying 50, that's wrong. You cannot write Iz equal to Ix plus Iy. It is only for XY plane. You have to always see the plane in which body has been placed. Yeah, okay, no problem. So everyone is giving correct answer, only one wrong answer came. Yeah. So body is placed in YZ plane means perpendicular to YZ plane will be our x-axis. So Ix will be equal to Iy plus Iz. Never remember according to perpendicular axis theorem Iz equal to Ix plus Iy. That's wrong. That is only applicable if the body is placed in XY plane. If the body is placed in YZ plane, our perpendicular axis theorem will become Ix equal to Iy plus Iz. Depending on plane, formula will change. Yeah, okay. So now this is given as 40. This is given as 10. From here you can find Iz. Iz will be coming as 30. So I gave you this question just to make you realize that depending on plane, we have to change the formula. Is it okay? Is it okay? बोल दो भाई. We'll move further. आगे बढ़ेंगे. Depending on plane, formula will change. Is it okay, Sare? Okay, no problem. Yeah, okay. Now we'll move towards our next theorem. Okay, no problem. Then we will combine all the theorem to study some numericals. Yeah, okay, no problem. So now we'll start with, okay, no problem, Manas. You can message me on WhatsApp, no problem. Yeah. So now we'll move towards our parallel axis theorem. You can write parallel axis theorem. You can write parallel axis theorem. Parallel axis theorem. Parallel axis theorem. Parallel axis theorem. This is the main theorem from where numericals are asked. Point is in origin means if axis will pass through origin, its moment of inertia will be 0. Yeah. No problem. At the end, I can give my contact number. Now focus on the class. We are going to talk about parallel axis theorem. Parallel axis theorem. No problem. Yeah. First, before writing the statement of parallel axis theorem, first I will give you some idea. So dhyan dena, be focused. Just see here. Yeah. What is meaning of parallel axis theorem? Where it will be used? So dhyan do. Just see here. Yeah. Okay. If you remember in perpendicular axis theorem, I was saying you it is applicable for only two-dimensional body. But if you look parallel axis theorem, it is applicable for all types of body. Whether your body is one-dimensional, two-dimensional, three-dimensional, doesn't matter. Parallel axis theorem is a versatile theorem. Parallel axis theorem is a theorem which you can use everywhere. You can use for ring also, you can use for disc also, you can use for hollow sphere also, you can use for solid sphere also, you can use for rod also. Means point is parallel axis theorem is applicable for all types of bodies. You can write this point. It is applicable for all types of bodies. In bracket 1D, 2D, 3D. It is applicable for all types of bodies. In bracket 1D, 2D, 3D. So always remember perpendicular axis theorem you cannot apply for all bodies. Perpendicular axis theorem is applicable only for two-dimensional body. But parallel axis theorem is applicable for all types of body. Doesn't matter what is its dimension. It is 1D, 2D, 3D. For all types of body, we can apply parallel axis theorem. No problem, no problem. Now, just see here, Yeah, okay. Just see what is meaning of parallel axis theorem. What is the use of parallel axis theorem? Just see here, yeah. And one of the most important theorem from where numericals will come. So, just see here, yeah, okay. Okay. Achha, if you remember in last class we studied moment of inertia of different bodies. Okay. Yeah, okay, no problem. But now be focused here. Yeah, okay. So we are going to talk about what is use of parallel axis theorem. Just see, yeah. In last class, if you remember, we studied moment of inertia of different bodies about axis which passes through its center. But it's not mandatory now, axis will always pass through center. For example, for rod, you remember moment of inertia about center. You remember moment of inertia about end. But if someone asks you find moment of inertia about this point, so always remember it's not mandatory that our axis will always pass through center. So if axis will not pass through center, then how to calculate moment of inertia? So always remember, whenever axis do not passes through center, if axis will pass through center, already we remember the value of moment of inertia, no problem, yeah. But if axis do not passes through center, then we must have a method to find moment of inertia. And that method to find moment of inertia is our parallel axis theorem. Always remember, parallel axis theorem help us to find moment of inertia when axis do not passes through center. And when axis will pass through center, already we remember the value na baba. For ring we studied, for disc we studied, all those axes were passing through center. But someone says, sir, if axis is not passing through center, then how to find moment of inertia? So always remember, when axis do not pass through center, moment of inertia we calculate with the help of parallel axis theorem. Parallel axis theorem is a method to find moment of inertia even when axis do not passes through center. You can write this point. It is used to find moment of inertia. It is used to find moment of inertia when axis do not passes through center. It is used to find moment of inertia when axis do not passes through center. It is used to find moment of inertia when axis do not passes through center. For center, we already remember. Apart from center, sir, how to find moment of inertia? So apart from center, whenever moment of inertia is asked, we have to use parallel axis theorem to get the value of moment of inertia. Again, I will revise the 2 points. Yeah. First thing, always remember, parallel axis theorem is applicable for all types of body. Someone says, then sir, what is the use of parallel axis theorem? Parallel axis theorem is actually used to find moment of inertia of the body about any axis. Any axis means if axis do not passes through center. If passes through center, we remember, sir. But if the axis do not passes through center, then how to find moment of inertia? Then we calculate moment of inertia with the help of parallel axis theorem. Parallel axis theorem is a method to find moment of inertia about any unknown axis. And the formula which comes with the help of parallel axis theorem. I said you parallel axis theorem will help you to find moment of inertia about any axis. Then sir, what will the method to calculate? What is the formula to calculate that? The way Pythagoras theorem was a formula now, actually parallel axis theorem is also a formula. And that formula says, if you want moment of inertia about any axis, any unknown axis you want moment of inertia, then you can calculate. This is what this formula says. This is what this theorem says. Moment of inertia of a body about any axis. Any axis means unknown axis. Any axis means the axis which is not passing through center. So I about any axis will be coming as I about center of mass plus md square. This is the final formula which comes with the help of parallel axis theorem. The way Pythagoras theorem was a formula, actually parallel axis theorem is also a formula to find moment of inertia about any axis. So moment of inertia about any axis, I any will be equal to I about center of mass plus md square. Now always remember this d is distance of new axis. Any axis means new axis now. So ICO means the axis which passes through center plus md square. Someone says, what is this d? D is distance of new axis. Distance of new axis from center of mass. So this is our actually parallel axis theorem. I any means the axis which do not passes through center. If it will pass through center, we already remember. I any means the axis which do not pass through center of mass. Yeah. M is the mass of the body. That is Monica. That is what is the use of parallel axis theorem. We'll do all those situations. Don't worry. Yeah. Is it okay? समझ में आया? Sir, if axis will pass through center, we remember. No need to calculate there. But if the axis do not passes through center, then how to find moment of inertia? There must be a method to find moment of inertia when axis do not passes through center now. That method is parallel axis theorem. I about any axis will be equal to ICOM plus MD square. Come on, everyone will say with me. I about any axis will be equal to I about any axis I any equal to. Come on, bolo. I any equal to ICOM plus MD square. I any equal to ICOM plus MD square. No one is saying. Say with energy. ICOM I any equal to ICOM plus MD square. I any equal to ICOM plus MD square. Sir, what is I any? I any means unknown axis. ICOM means what, sir? Axis which passes through center plus MD square. Sir, M is the mass of the body. What is D? D is the distance of new axis from center of mass. D is what is D, sir? D is the distance of new axis from center of mass. Is it okay? बोल दो भाई. I any will be equal to ICOM plus MD square. Is it okay? I any equal to ICOM plus MD square. Is it okay? एक बार बोल दो भाई. Now ध्यान दो. One more important point is left. ध्यान देना. Be focused. Develop understanding what I'm trying to tell. Develop understanding. Just here. Yeah. Okay. No problem. Yeah. I any will be equal to, sir, ICOM plus MD square. No problem. We will get the moment of inertia about any axis. Now ध्यान दो. Just here. Yeah. Okay. Now you will be thinking, sir, name of the theorem is parallel axis theorem. But till now, nowhere you have used word parallel. This is the main point where students get confused in the exam. So name of the theorem is parallel axis theorem, but till now, nowhere you have used word parallel. What is the significance of word parallel in its name? Always remember, through center you can pass 100 axis now. For example, this my hand is there now. Through the center of my hand, this is the center of my hand, I can pass 100 axis. This axis also, 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 this axis also. Then which axis I have to take for moment of inertia? And through center of mass 100 axis can pass now. Which axis I have to consider for moment of inertia? That axis must be parallel to our new axis. That's why name is parallel. Always remember this INE and ICOM. These are the two axes here. INE and ICOM. These two axes must be parallel. That's why name of the theorem is parallel axis theorem. Means you have to use that value of ICOM which is parallel to our new axis. You cannot use any value of ICOM. Sir, any value of ICOM you cannot use. You have to use only that value of ICOM which is parallel to our new axis. That's why name of the theorem is parallel axis theorem. Is it okay? Bol do bhai. We can compare moment of inertia of only two parallel axes. Out of them, one must be passing through center. So these two axes must be parallel. So I any will be equal to ICOM plus MD square. Someone says, sir, why name is parallel axis theorem? Because ICOM and INE both must be parallel. I will give you one question. Some questions we will do from here, 4-5 questions which are very, very important. Directly these questions are asked in the NEET exam. I will give you one question. Come on. You write. Find moment of inertia. Now I'll give you axis and none of these axes will pass through center. Mainly they will be tangential axis. Yeah. Find moment of inertia of a solid sphere. Find moment of inertia of a solid sphere about an axis. Find moment of inertia of a solid sphere about an axis along its tangent. Find moment of inertia of a solid sphere about an axis along its tangent. Remanth, very good. People remember also value, but if you remember then also find. If you forget, you can use parallel axis theorem to get the answer. Find moment of inertia of the solid sphere about an axis along tangent. Mass of the sphere M, radius R. Yeah, very good, very good. Remanth, very good. Vasishta, very good. Manas, very good. Venkat Shiva, very good. Saroja, very good. Chandana Shri, very good. Pravalika, very good. Yeah, okay, no problem, no problem. Amrut, very good. Yeah, most of the people are getting. Some people may be feeling problem or some people remember. See here how to get with the help of, yeah, Gyaneshwari, very good. Yeah, how to get the value of moment of inertia with the help of parallel axis theorem. Better you can remember. For solid sphere it will come for 7/5. Better you can remember, but even if you forget, see the process. See the process how to calculate moment of inertia about tangent of a solid sphere. Dhyan do. Here you will get more clarity of parallel axis theorem. So dhyan do, just here. Yeah, okay. Now first thing. Sir, this axis is not passing through center now. This is any other axis now. Dhyan do, we have written INE equal to ICOM plus MD square. INE means the axis which do not passes through center. So this axis is tangent now. Tangent now means this axis is not passing through center now. If this axis is not passing through center, we will name this axis as any axis. So INE will be equal to, now I'll write parallel axis theorem. INE will be equal to ICOM plus MD square. INE will be equal to ICOM plus MD square. No problem. Yeah. Now ICOM means the axis which will pass through center. Tell me, shall I take ICOM like this? Shall I take ICOM like this? Shall I take ICOM? ICOM is the axis which passes through center. I can pass one axis through center like this na. Shall I take ICOM like this? Shall I take ICOM like this? Jaldi batao bhai. Shall I take ICOM? No. Always remember ICOM and INE both must be parallel. Randomly you cannot take. Sir, I will take ICOM like this. Someone will say, sir, I will take ICOM like this. No. You cannot take like this. Both axes must be parallel. That's why name of the theorem is parallel axis theorem. So I will draw one ICOM which is parallel to it. And that ICOM will be like this. This is our ICOM for this INE. And this ICOM we already know 2/5 MR square. Now someone says, sir, what will be D? D means distance of new axis from center. So this is the new axis passing from here. This is the distance, sir. This distance will be equal to, sir, radius. Once we know, now we can dump there to get our answer. So moment of inertia will become, sir, 2/5 MR square plus MD square. D is also R, sir. So MR square. That means final answer will become 2/5 plus 1. That will give you 7/5 MR square. If anyone asks you radius of gyration, you can equate to MK square. You'll get the value of K also. K will become, because many times they ask radius of gyration. So radius of gyration will become under root of 7 by 5r. Is it okay? समझ में आया? बोलो 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 त्वरगा. The two axes must be parallel. That's why name is parallel axis theorem. Yeah. Come on, do the next one. Come on, do the next one. Again, one easy one. You write, find I of a hollow sphere. Find I of a hollow sphere about tangential axis. Find I of hollow sphere about tangential axis. 5 by 3 mr square again. So tangential axis means this is our tangential axis. Now this axis is not passing through center now, so this is again INE. Again INE will be equal to, sir, ICM. This is the ICM parallel to it, sir. And this ICM we already know, sir. This ICM we already know, sir. 2 by 3 mr square. ICM plus MD square. Sir, what is D? D is again R. So plus mr square. That means from here it will come, sir, 5 by 3 mr square. If anyone asks me radius of gyration, I will equate to mk square. So from there k will be coming as under root of 5 by 3r. Is it okay? Is it okay? Bolo 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 bolo. Is it okay? Very good. Pavitra said, Lakshmi said, Chandashri said, Shiva said, yeah. Is it okay? Is it okay? बोल दो भाई, बोल दो, त्वरगा टाइम ले दो. Yeah. Is it okay? Now two very, very important situations we are going to talk. Now ध्यान देना, be focused. Main part from where question. These are also important. But if you see previous year NEET question 6-7 times they ask for two bodies which are very, very important. ध्यान दो, be focused. NCERT solved example is also there related from here. So be focused, understand. Be focused, yeah. Okay. बहुत बढ़िया. ध्यान दो. Be focused. Just here, yeah. Okay, no problem. Yeah. Okay. Acha, always remember here very easy to talk. Because these are three-dimensional body now. Here I will say tangent. I am simply saying tangent. But when I will have two-dimensional body now, when I will have ring and disc, there two tangents will be possible. One tangent will be perpendicular to plane. Other tangent will be parallel to the plane. If you remember the last class, only I said you this point. ध्यान दो what I am trying to tell. 3D bodies don't have any plane, so that's why we will say axis passing through center, axis along tangent. But whenever I will talk about ring and disc now, there I have to say tangent parallel to the plane, or tangent in the plane, or tangent perpendicular to plane. ध्यान दो what I am trying to tell. For example, just here, yeah, okay. Assume this is the ring. Assume my hand to be ring. Assume this is the ring. Always remember, for ring, two possible tangents will be there. This is also tangent to the ring. This is also tangent to the ring. But both tangents are different. That's why moment of inertia will come different. ध्यान दो. For a sphere, I don't have to say parallel to the plane, perpendicular to the plane. Directly I can say tangent. But two-dimensional body means plane will be there. So that's why here two tangents will come. देखो एक बार. If this is the ring, one tangent, can you tell me what will be name of this tangent? This is also tangent. This is also tangent. How you name this tangent? Tangent. This is also tangent. Tangent perpendicular to the plane of the ring. This is a plane of the ring, na bhai. Tangent perpendicular to the plane. And this is tangent parallel to the plane. Is it okay? Are you understanding two tangents here? Yeah, okay. So one tangent, this is also tangent, this is also tangent. So this is tangent perpendicular to the plane of the ring. This is tangent parallel to the plane of the ring, or you can say tangent in the plane of the ring, or you can say tangent parallel to diameter. Now just see, very important, yeah. Now what will happen when you calculate moment of inertia about this axis? Now tangent perpendicular to the plane. ICOM will be also perpendicular to plane. And ICOM perpendicular to plane means for ring, it will be mr square plus mr square. You'll get moment of inertia 2 mr square. Are you getting idea what I'm trying to tell? बोल दो भाई, बोल दो. Here answer will change. One case answer will come 2 mr square, other case answer will come 3 by 2 mr square. Students remain confused. In which situation it will come 2 mr square, in which situation it will come 3 by 2 mr square. Game is of ICOM, game is of parallel axis theorem. एक बार फिर से देखो. When you take this as your axis now, tangent perpendicular to plane, ICOM will be also perpendicular to plane. And ICOM perpendicular to plane for ring is mr square. So mr square plus mr square answer will become 2 mr square. But when you take tangent parallel to the plane, ICOM will also come parallel to the plane. Parallel to the plane means it will come along diameter. If it will come along diameter, now ICOM will become mr square by 2. So mr square by 2 plus mr square will give you 3 by 2 mr square. Are you getting idea what I'm trying to tell? Bolo jaldi. Now you can write the question. Now you can do. Yeah. I will send slide at the end, no problem. You can do one question, come on. Same two axis I will ask. You can write. And don't do mistake. Find moment of inertia of a ring. Find moment of inertia of a ring. Find moment of inertia of a ring. Find moment of inertia of a ring about tangential axis. About tangential axis. Find moment of inertia of a ring about tangential axis. First, perpendicular to its plane. Two tangents will come. About tangential axis, first perpendicular to the plane. Second, parallel to the plane. Parallel to the plane. Both of the axes are not passing through center means you have to use parallel axis theorem to find moment of inertia. First one, when your tangent is perpendicular to plane, ICOM will be also perpendicular to plane. So ICOM perpendicular to plane for ring is mr square plus md square. That will give you 2 mr square. First one, very good, very good. Everyone is giving answer. बहुत बढ़िया, बहुत बढ़िया. First one answer will come 2 mr square. Second one, when you calculate parallel to the plane, ICOM will also come in the plane. So ICOM will become 3 by 3 mr square by 2 plus mr square. 3 by 2 mr square. First one answer will come 2 mr square. Second one answer will come 3 by 2 mr square. Very good, very good. Everyone got, nothing to worry, nothing to worry. So एक बार देख लो, no problem, no problem, no problem. Yeah. Okay, no problem, no problem. Yeah. So just for, I think you got, but still, if someone is feeling problem, see once again. You'll get 100% clarity. Just see here, yeah, okay. I was talking about ring. This is how, whenever ring is asked, whenever you have to draw ring, always draw ring like this. Then only you'll be able to represent the axis which is perpendicular to the plane. No problem, yeah. First axis tangent. First axis tangent and perpendicular to plane. This is the first one. Tangent perpendicular to plane means about this IME will come. Now if you take this, ICM will be also perpendicular to plane. And you know here ICM will be coming as mr square. So mr square plus ICM plus md square. D will be equal to R. Our D will be equal to R. So D will be equal to R means mr square. Answer will come 2 mr square. If anyone asks you radius of gyration, equate it to mk square. Because sometimes they ask K. K will be coming as root 2R. Second one, they are saying you tangent in the plane. Tangent in the plane means your tangent will be like this. Tangent in the plane means this is a tangent. I cannot represent there because things will be in 3D. Tangent in the plane. So now ICM will be like this. Now ICM will be like this. Now again you can find tangent in the plane, I will come, sir. IME will come. Now you can see ICM is along diameter. ICM is along diameter, that means it will come, sir. MR square by 2 plus MD square. D will be again R plus MR square. That will become 3 by 2 MR square. If anyone asks you radius of gyration, here you can calculate radius of gyration also, because many times they ask K value. So from here K value also you can find. If you equate it to MK square, you will get radius of gyration. K will be coming as under root of 3 by 2R. Is it okay? Bol do bhai. Everyone got the idea? Understood? चमका बता दो एक बार. चमका क्या? Is it okay? Is it okay? So sometimes they ask I, sometimes they ask K, sometimes they ask ratio also. So game is of parallel axis. ICM will change if you change your plane of the axis. If you understood this, do the next question. Do the next question. Come on. I think next everyone will be able to do. Yeah, okay, no problem. बहुत बढ़िया. You do the next question. Come on. Find I of a disc. Find I of a disc about tangential axis. Find I of a disc about tangential axis. First, perpendicular to its plane. First, perpendicular to its plane. Second, parallel to its plane. First, perpendicular to its plane. Second, parallel to its plane. Very good. Manas has given both answer. Mahita, you have given only first answer. Second answer also you can give once you understood this. Yeah. Venkat Siva, very good. Harudev, very good. Srikar, very good. Mahita, second answer also correct. Remant, both answers correct. Manogna given only one answer correct. Amrut, both answers correct. बहुत बढ़िया. Yeah, first one answer. Yeah, Manogna, both answers correct now. Yeah, Ganesh, very good. Srikar, very good. Now, first situation when you get tangent perpendicular to plane, so ICM also you have to take perpendicular to plane, and that is MR square by 2. So MR square by 2 plus MR square, it will become 3 by 2 MR square. Second situation, tangent in the plane, so ICM will be also in the plane, and that is along diameter. So MR square by 4 plus MR square, it will give you 5 by 4 MR square. बहुत बढ़िया. Everyone is getting no problem at all. First one answer will come, sir. If you are talking about disc, first one answer will be coming as, sir, IME will come, sir. ICM will become tangent perpendicular to plane, so ICM will be also perpendicular to plane. That is MR square by 2 plus MR square. That will give you 3 by 2 MR square. So second one you are talking about tangent in the plane. So if tangent will be in the plane, ICM will be also in the plane. That is MR square by 4 plus MR square. That will give you 5 by 4 MR square. If anyone asks you radius of gyration, equate it to MK square. Here K will come under root of 3 by 2R. And here K will come under root of 5 by 2R. Is it okay? Bol do bhai, bol do. Torga. Done. Then I'll give you one more question related with rod. Is it okay? Is it okay? Chalo, I'll give you one more question. Yeah. Okay. बहुत बढ़िया. हाँ. Now I'm giving you a rod. And for this rod, again, axis is not passing through center. For this rod, axis is this. Here somewhere center will be there, no problem. So mass of the rod M, length of the rod L. This distance is given as L by 4. You have to tell me moment of inertia of the rod about this axis. This is your INE because it is not passing through center. So this is INE. You can calculate. Okay, Akash, that you can do by yourself. Remant, how ml square by 3 will come? Why ml square by 3 will come? That is not end. Axis is not end. When axis is end, then it comes ml square by 3 na baba. When axis is end, we get ml square by 3. Na axis is not end. Wrong, Saroja wrong, Vasishta wrong, Amrut wrong. Here one mistake students do. That's why I have given you this question. There is one common mistake which is done by student. Ravi has given correct answer. Ravi Dhanush has given correct answer. Vaishnavi wrong. ध्यान दो, be focused, be focused, be focused, be focused, be focused. Yeah, be focused just here. Okay, no problem. Yeah, okay. ध्यान दो just here. See the mistake. Identify the mistake which you are doing. Many of you are doing this mistake. I already know. ध्यान दो just here. Yeah, okay. हाँ. Okay, no problem. Yeah. अच्छा, are you doing like this? Sir, about this axis, I know, sir. About this axis, moment of inertia will come, sir, ml square by 3. So, about this axis, moment of inertia will become, sir, INE will become. About this axis, I know, sir, ml square by 3 plus md square. What is this, sir? L by 4 square. Are you doing like this? Anyone is doing like this? Ganesh, correct. Are you doing? Yeah. Huh. Likita, correct. 7 by 48 ml square will come. Never do like this. This is wrong, Baba. This is a very common mistake students do. They say about this, I know, sir, ml square by 3 plus mds. You cannot do like this. Here you don't have any value of moment of inertia. This is completely wrong. This is not ICOM. You cannot start from end and you can go anywhere. Always you have to start from center. Yeah, now people are giving correct answer. Shyam very good, Sumraja very good, Nalli very good. Yeah, people, this is a very common mistake. That's why I show you the mistake. What students do in hurry, what students do about this, I know, sir, ml square by 3 plus md square. Wrong. It's not any ml square by 3. It's not any moment of inertia. It's always center. This is wrong. You cannot write end plus md square. Wrong. Always remember, you have to always start from center. That is the meaning of parallel axis theorem. ICOM, not end, not ml square by 3 plus md. Wrong. ml square by 3 is not center. You have to always start from center. So from center you will start. Sir, center I know ml square. This is your axis. This is your ICOM. So ICOM I know, sir, ml square by 12. Plus md square, and d you can calculate. D you have to calculate. D is the distance of new axis from center. So from center, distance of new axis will become this distance you can find, because this total is L by 2. This is L, this is L by 2. If this is L by 2 and this is already given L by 4, so this distance, this remaining distance will become L by 2 minus L by 4. That will come L by 4. So md square, that is L by 4 whole square. If you solve this, this will give you 7 ml square by 48. Did you understood? I did not give you this question to get the answer. I just wanted to tell you the common mistake which students do. They start using formula from anywhere. No, Baba, it's ICOM plus md square. ICOM first you have to write, then you have to add md square. Not ml square by 3 plus md square. It will become wrong. Is it okay? Bolo, 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 Twarga. Bolo, bolo, jaldi. Is it okay? बोल दो एक बार. D means distance of new axis from center. It was given from end, so you have to find distance from center, and luckily it came same because this was L by 2, so and this was L by 4, so this distance was also L by, yeah, okay. Now ध्यान दो, be focused, just here, okay, no problem, we'll do more question, ध्यान दो, just here, okay. Now before moving to next question, I will tell you one theoretical point which is very famous in parallel axis theorem. Yeah. अरे how you can take Chandra Sri L minus L, पागल हो गए हो क्या? You want distance from center ना? Center distance is L by 2 ना? This is distance is L by 4 ना? So it will come L by 2 minus L by 4. How it will come L minus L by 4? कुछ भी मत करो भाई, you have to see the distance from center ना, center is L by 2 ना, L by 2 minus L by 4, that is L by 4. No problem. Now ध्यान दो, be focused, yeah, okay. Okay. One theoretical question is very important here which is asked again and again. ध्यान देना, be focused, just here, yeah, okay, no problem. अच्छा, if you observe the formula given by parallel axis theorem now, parallel axis theorem is trying to say you something again and again. It is trying to tell you one theoretical point again and again. So that theoretical point I am talking about, just here, yeah, okay. अच्छा, always remember from this equation from parallel axis theorem, you can always say that moment of inertia of the body will be minimum about center of mass. ध्यान दो. If I am the body, through my body 100 axes are passing, all axes will have different moment of inertia, but moment of inertia will come minimum about the axis which will pass through center of mass, because about center of mass you will get moment of inertia only ICM. For any other axis you have to add extra na baba, md square na baba. ध्यान दो what I am trying to tell, just here. And for any other, for center of mass, moment of inertia is ICM. For any other axis, what is moment of inertia? ICM plus md square. Extra md square you have to add for any other axis. That means about center, moment of inertia will be minimum. For any other axis, moment of inertia will increase. Are you getting this point? Bolo jaldi. Are you getting this idea what I am trying to tell? About center, moment of inertia will be maximum. About any other axis, moment of inertia will increase. And if distance is more, I will be also more. Bolo, jaldi. And for any other axis, you have to add extra na md square. If you add extra md square, moment of inertia will increase. Now you write this point. You write. From parallel axis theorem, we can say that I of the body will be minimum about from parallel axis theorem we can say that I of the body will be minimum about center of mass. From parallel axis theorem we can say that I of the body will be minimum about center of mass. From parallel axis theorem we can say that I of the body will be minimum about center of mass. And as the distance will increase from center, and as the distance will increase from center, come on, tell me, as the distance will increase from center, what will happen to I? If the distance from center increases, what will happen to I? Increase or decrease? As the distance increases from center, I will, अरे बोलो भाई, I will, and as the distance increases from center, I will increase. This is also a question which came previously in the NEET. They said one disk is there, and they said for this disk 3 axes they gave. They said about axis through center, moment of inertia was I1. One axis they gave, yeah, distance, as the distance will increase, I will increase. And they said about one axis passing from here. They said about this moment of inertia is I2. And they said one axis passes from here, I3. Can you tell me which is maximum and which is minimum? Yeah. Which is maximum and which is minimum out of I1, I2, I3? Which is maximum? Which is maximum? Which is minimum? Which is maximum, which is minimum? Jaldi bata do. I3 will be more because distance from center is more na. I3 will be maximum. I1 will be minimum because distance is 0. That is the central axis passing through center. So here we will get I3 maximum, then I2 minimum will be I1. This is the order. So this is how we talk about, okay, no problem. Yeah, I1 passing through center, D will be 0, moment of inertia will be minimum. I3 maximum distance, moment of inertia will be maximum. So this is how without value also you can compare which will be more, which will be less with the help of parallel axis theorem. Is it okay? Is it okay? बोल दो भाई. Is it okay? Okay, no problem, no problem, no problem. Yeah, okay. Sometimes questions are asked where they will combine 2-3 bodies. Right now we are talking about one sphere na. I am talking about one disc na. Tomorrow they can say 2 discs are combined, or 2 spheres are combined, 3 spheres are combined, and there they will ask you find moment of inertia of the system. Then in that situation you have to find every moment of inertia and you have to add in order to get total moment of inertia. Dhyan do. For example, for particle also I said like 3 particles are there, the total moment of inertia will become I1 plus I2 plus I3. Like that only in the system if 3 spheres are there. Then you have to find every moment of inertia, add them, you'll get total moment of inertia. I will give you one question. Come on. I will give you a previous year NEET question. These are spherical shell. Shell means hollow sphere. Spherical shell means hollow sphere. All are identical. All have same mass m. All have same radius r. No problem. So these are 3 spherical shell. Shell means hollow sphere. You have to tell me moment of inertia about this axis. So for every one you have to find moment of inertia, add them, you'll get the answer. You have to check for first spherical shell. Shell means hollow sphere. Yeah. Pravalika, very good. Yeah. For first spherical shell, time is not there. Yeah. So for first spherical shell, if you see, axis is through center na baba. Spherical shell means hollow sphere na. So for first hollow sphere, axis is center na. You know na for hollow sphere about center 2/3 mr square. Our answer will come 4 mr square, 12/3. This is hollow sphere na baba. For this hollow sphere, axis is center na baba. So center axis you studied na 2/3 mr square. For this hollow sphere, axis is tangent na. Tangent na, just how you calculated na about tangent, it will come 5/3 mr square. For this also, axis is tangent na. So for this also it will come 5/3 mr square. That means total moment of inertia of the system will become I1 plus I2 plus I3. 2/3, 5/3, 5/3. That will give you 12/3 mr square. Now from here you can get answer 4 mr square. Are you getting idea? Bol do bhai. Are you getting how to find when combination of bodies are given? 2, 3, 4 bodies are given. जल्दी बता दो. हाँ वेरी गुड. चलो एक और बना लो. कमन तोड़गा 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 तोड़गा. These are solid spheres. All are solid spheres. Each of mass m, radius r. You have to find I of the system about the given axis. That will come in the next week. Shyam, that will be next week. जल्दी बता दो भाई. For this you will simply say, for this sphere, solid sphere, for this solid sphere axis is center na, so 2 by 5 mr square. For this solid sphere also axis is center na, 2 by 5 mr square. For this solid sphere axis is tangent na, 7 by 5 mr square. For this solid sphere also axis is tangent na, 7 by 5 mr square. Add them, you'll get total. So 7 7 14, 14 plus 4 18, 18 by 5 mr square. Is it okay? Bol do bhai, bol do. Come on. Chinna question, just whatever we have studied we are just adding. No problem. Do one more question. Come on, do one more question. Again, one easy question. Come on, do it fast. You write. You write. Okay, no problem. Yeah, you can write. You write two identical rods. This is also famous question. Two identical rods are joined to form a cross structure. Two identical rods are joined to form cross structure. Find I of the system about an axis passing through their center. Find I of the system about an axis passing through their center and perpendicular to the plane. Find I of the system about an axis passing through their center and perpendicular to the plane. ml square by 12 plus ml square by 12. And for both rod axis is this the baba. For both rod axis is perpendicular na. For both rod axis perpendicular na. For this rod also axis perpendicular. For this rod also axis perpendicular passing through center. So each rod will have ml square by 12 plus ml square by 12. When you solve this will give you ml square by 6. So actually it's very easy. Actually it is very easy. Is it okay? You write the next question. Come on, one more chinna question we are talking about. No problem. Yeah, okay. You can do one more question. Come on. You write, three rods are placed along the three axis. Three rods are placed along the three axis. Find I about Z axis. Find I about Z axis. Three rods are placed along three axes. Find I about Z axis. So one rod is already on the axis, its moment of inertia. For this rod, I about Z axis means this is our axis of rotation. So one rod already on the axis. So for this rod, moment of inertia will become 0. 2 by 3 ml square. Yeah. For this rod, axis will be end. Axis end means ml square by 3. For this rod also, axis is end means ml square by 3. That is total moment of inertia. One rod is already on the axis na baba. You know na when the particle is on axis, moment of inertia will come 0. For this rod already 0. For this rod ml square by 3. For this rod also ml square by 3 because axis is end. So total moment of inertia you can add. So system moment of inertia will become 2 by 3 ml square. Is it okay? कुछ समझ में आया क्या? Come on. 2 by 3 ml square. So this is how we talk about. We will do some more situations like removed body from that are in the next week. Next week also we will study for some time moment of inertia. So this is how we have talked about more situations. From here we'll be talking in our next class. For today we'll be ending here only. I will give you homework, send you homework, do the homework. Tata, bye bye, take care, bye. Bye bye. Why to use perpendicular axis theorem? This is 3D body now. How you use perpendicular axis theorem? Okay, bye. Take care. Bye.